Hello, this is the first video in preparation for your mock examinations, and I'm going to take you through the topic of storage, which was the very first topic we did in year 10. And I've taken you to the knowledge organizer that you've all got a copy of in your year 10 exercise book right at the start. This knowledge organizer was put together for the first two topics, storage and memory. So I'm just going to take you through the storage things in this first video. So the first thing is the definition at the top of secondary storage, and the key things you need to put in a definition when you're giving the definition of secondary storage or saying what the purpose of secondary storage is. So secondary storage is needed to store data, but it's needed to permanently store data because it's non-volatile. And what we mean by non-volatile is that we don't need the power to retain the data. Don't get that confused with not needing power to save the data. You do need power to save the data. It just means when the power is lost, the data is not lost. When you turn your computer off, the data is not lost. That's what non-volatile means. So it means it permanently stores the data. So that's why we need secondary storage devices to permanently store our data. Okay, so whenever you get a question about secondary storage, make sure you get the word store data in there. Make sure you hammer home the point it permanently stores data because it's non-volatile, and make sure you get that definition of non-volatile in there, which means when the data is retained when the power is lost, and it doesn't lose data when we turn off the power. Okay, so you've really got your definition of non-volatile there. It does not lose data when the power is switched off. Other things you need to know as part of secondary storage is being able to convert between the different measurements. Okay, so remember, bit is a single binary digit, a 1 or a 0. So BI coming from there, and the T on the end of digit, single binary digit. So therefore a nibble is 4 of those bits, and a byte is 8 of those bits. Okay, and then you've got your kilobyte, which is 1,000 bytes, and then you've got a million bytes, a billion bytes, a trillion bytes, and a quadrillion bytes, okay, with 3 extra zeros being added on each time. Okay, so make sure you can recall that. Factors to consider when purchasing secondary storage. So we've got those listed here. So physical dimensions, we don't use the word size. We don't use the word size. We either use the word capacity or dimensions. So another thing you could consider when purchasing a secondary storage device is capacity, its read-write speed, its durability or robustness, its portability, its reliability, its compatibility. So there's loads of different factors to consider. Make sure you can recall 4 or 5 off the top of your head. So you've got your definition of secondary storage and keywords in there. You've got your definition of non-volatile. You've got your conversions and bits and bytes there. You've got the things you need to consider when you're purchasing secondary storage there. We know that we never use the word size. We need to use the word capacity or dimensions. So you've got 3 different types of technology under secondary storage. The common storage technologies are optical, magnetic, and solid state. So if we take optical first, CDs, your DVDs, your Blu-ray discs, inexpensive, particularly to mass produce, lots of copies of the same thing. Compatible, people probably already have a CD or DVD drive. In terms of capacity, that's limited and it takes time to burn the discs. If you think magnetic, okay, so it's more affordable than solid state for those higher storage capacities. And tends to come in higher storage capacity. If you want really large servers, they are going to be magnetic. Slower read-write speeds in comparison to solid state. Higher power consumption, produces noise because they've got moving parts and therefore are susceptible to damage, and therefore not as durable, but they are reliable. If they're used in a static condition and kept still, they are very reliable. And finally, solid state, they are faster to read and write than magnetic. They have a lower power consumption than magnetic and are more durable. They have no moving parts. They're not susceptible to damage in the same way. They don't produce noise. They're more compact, smaller physical dimensions, can be used in portable devices, but they're going to be more expensive than magnetic for a similar capacity, and they do have a shorter lifespan. If you're asked to compare any of these, don't just say the opposite all the time. Try and think of unique points for each one. So for instance, don't just say solid state is faster than magnetic and magnetic is slower than solid state. I think that's two separate points. That is just one. Okay, so think if you've got a 6-mark question, how many points you're going to have to make, and don't just duplicate the same 3 points. The final thing on the topic of storage is being able to calculate the minimum storage calculations for different types of files. So first of all, you need to be able to do text files, and to simply work that out, you just take 1 byte per character. So if a text file has 1,000 characters, it's 1,000 bytes to store. You don't have to add in 10% for the metadata, but you can have that allowed for in your answers on the mark scheme as well by multiplying it by 1.1. So a text is just 1 byte per character. So if a text file has 5,000 characters, it's 5,000 bytes. And remember, you can use this scale down here to get it in a more appropriate unit of measurement. For images, you need to take the resolution and multiply it by the color depth. Make sure your color depth is in bytes. So if it's got a color depth of 16 bits, you are not multiplying it by 16 for the color depth, you're multiplying it by 2. Remember, the resolution will already be 2 numbers multiplied together, so you actually end up multiplying 3 numbers together there. Resolution times color depth. Just make sure your color depth is in bytes before you multiply it by the resolution. And again, you can times it by 1.12 factor in the metadata, but you don't have to. And again, just make sure you turn color depth into bytes first. For a sound file, okay, you need to take the bytes per sample, multiply it by the samples per second, multiply it by the channels, and then multiply it by the duration. So in effect, multiply every number together. Just remember, duration needs to be in seconds. So if it gives it you in minutes, just make sure you turn it into seconds. And again, with the answer you get, try and turn it to an appropriate unit of measurement. The final type of file you might need to be able to work out the minimum storage capacity for is a database. Okay, a database has a certain number of fields, okay, and a certain number of records. So we work out what one record would take to store first. Okay, so you take each field and add their capacity together first. So it might say a text file of 8 characters, a number and a date. So you do the 8 bytes plus the 4 bytes plus the 8 bytes for a date, and then you've got what it is for one record. Okay, so a text again is 1 byte per character if it's a text field. Integers take 4 bytes, real numbers take 4 bytes, and a date takes 8 bytes. So you need to look at the data type of each field, and for one record, work out how many bytes one record is going to take. So as I said, if it's a text field of 8 characters plus an integer plus a date, that's 8 plus 4 plus 8, which is 20 bytes. You would times that by however many records there are. So there might be 100 records. So you do 20 times 100, and that's how much your database would take. And then you can obviously factor in metadata if you want to, and times by the 1.1. Otherwise, you would just get it into the appropriate unit of measurement. That's the topic of storage. My next video tomorrow will be on the topic of memory, which is the second topic we did in year 10.